Hello, my name is Arben Kalziqi with the Wolfram U team here at Wolfram Research, and today I'm going to tell you a little bit about Wolfram Notebook Assistant as well as basic chat functionality. That is a discussion about AI assistants in Wolfram Notebooks. Our learning objectives today are as follows. First, we're going to understand how to access and utilize Wolfram Notebook Assistant. It's not much use if you can't access it. Then we'll learn about some of its key uses, asking for code, improving your own code, doing image analysis, accessing all sorts of built-in data, the kind of hand-curated data that powers Wolfram Alpha, and even creating, say, web-deployed interfaces. And at the end, we'll have a brief discussion about utilizing chat cells directly in your notebook instead of in the little Notebook Assistant window that you see to the side here. The first thing to note about accessing Notebook Assistant is that it uses Wolfram's LLM kit to combine the broad intelligence of LLMs with a very focused knowledge of Wolfram Language's extensive documentation system. We have almost 6,500 functions as of the time of release of this video class, and Notebook Assistant knows about all of them. So here's how you can access Notebook Assistant given that you have LLM kit already. You can access it through the menu here if we just click Help, and then Notebook Assistant Chat. If we click this, that will produce this little window that we see on the side where we can talk to Notebook Assistant. And you'll also see there that there's a corresponding keyboard shortcut. Here on Mac, it's Control''. On Windows, it may be Alt'', but if you just go to the Help menu, you'll see the shortcut for your keyboard and operating system listed right there. You can also access Notebook Assistant via a toolbar button. As a veteran user, I tend to have the toolbar hidden by default, but you will likely have it open, and if you just click on here, you can see that there's a button right here under Assistance, which will allow you to open up a Notebook Assistant window. And then we'll talk about this more at the end, but you can open up a chat cell in your notebook without having to leave the notebook interface at all. That is, you don't have to go to a second window, just by typing an apostrophe. Note that this does require Wolfram Language 14.2 or later in order to have this integrated chat notebook functionality. And if you don't already have an LLM Kit subscription, there's a link here to a free trial so that you can give all the stuff that you're seeing today a shot. Okay, now that you know how to access Notebook Assistant, let's see some of its key uses. You can do a lot of different things. Let's start with something maybe a little basic in terms of the coding. We could say, how do I find the running maximum of a list? That's going to give us a response. Okay, so this gives us two options, one using a built-in function and one using a resource function. These are functions where, if you didn't think that the 6,500 built-in functions were quite enough, users have submitted all sorts of functions that have extended, well, functionality to our repository of functions. And you can access those right in your notebook. And here, Notebook Assistant knows about that repository and is accessing it. And a very important thing about interacting with Notebook Assistant here is this Insert and Evaluate button. So if you just click this, it puts the code right in the notebook for you, and it runs it. So you can see the input and the output. And once you have the input and the output, you're ready to start messing around, right? So let's say we start from 0, and let's say instead of finding the max, maybe we want to find the min. Surely we could do this, and maybe we need some lower numbers here, like let's say a -5. And if we run this with Shift-Enter, just as we usually would in a Wolfram notebook, we can see that we start at 0, we stay at 0, and then eventually we get to -5, and that becomes the new running minimum of the list. So we've got an answer, and we also have a way to move forward with related problems. You can also do things like ask, let's say, how could I import and plot a CSV file? Could you use an example and show me how to do it? Just press Enter to send over here. Okay, so it says we should use import. And then we can use date list plot or list plot depending on the type of data. here it says, okay, step 1, import the CSV file. So let's go ahead and insert and evaluate that. There it is, and there's some example data. It's a financial time series. And then it says, well, once you've done that, you can just use dateless plot just like this. So let's insert and evaluate it. And there we go. We can see that this data was plotted via dateless plot. And we have some, axes, label options, and image size options here as well. And I have to say, a lot of times if you don't really know how to do something yet, just getting the function that does it is going to be a huge service to you. Because once you have that function, you can just mouse over it, and you can click this little I, the information I, and this will bring up the documentation page for it. For me, it opened up on a secondary window. Let me bring it over here. And then once you have this, you can go through and read all about the function. You can see all sorts of different examples. You can see, different scoped things that you can do with this thing. So maybe you want to work with some special data that has quantity units, for example, like meters. Or maybe you want to read about all of the different possible options available for dateless plot. That's all right here in the documentation. And once you have the name of the function through Notebook Assistant, you're kind of ready to go. And, this kind of forms a cycle. Notebook Assistant knows about all of this stuff. So you could look at the documentation yourself, and you could ask about the different options. How would I make the color of the plot red? Or how do I make the line thicker? Things like this. These all work with Notebook Assistant. You can ask for, maybe a couple different ways of doing something. If you're brand new and you want to see, okay, what's possible? What are the different ways to do this task I have in mind? You could say something like, show me a few different ways of making a list where all of the prime numbers are framed. Okay, so we get a couple of options here. All of these using an if statement, which is A-OK. This one uses table. This one maps this pure function. That's like a lambda function if you're familiar with it from another language. If you're not familiar with it, don't worry. Basically, this is just a place that is going to accept a variable. So it says, if the thing you're feeding to me is prime, then frame it. Otherwise, just give it back to me unchanged. And we can insert and evaluate all of these, just like before. I accidentally double-clicked that, but you can see the results here. All the prime numbers are framed. The same thing will be true with this one. And you'll get the same output for parallel map as well. So that might be something that's worth knowing about if you have a computer with a lot of CPU cores. This is on one of the M-series chips, so you might have caught that there are 14 parallel kernels running. For a small task like this, that's not really an efficient use of your time, but for a big task, it can be a real speed up. And Wolfram language has a lot of functionality to it that if you're new to functional programming, it might not be so obvious at first. So let's say, I've kind of a pre-made example here. Let's say I don't know anything about functional programming, right? And what I've got here, so I'm going to clear my symbol F. I'm going to use this built-in function to make a random 3x5x4 array or nested list of random integers between 0 and 9. And then my idea is that I'd like to take the function f and apply it to all the random integers. Not to the rows, not to the columns exactly, but to all of the integers themselves that live in this rank 3 array. If I don't know anything about functional programming, I might think that the way to do that is, well, I have to start with an empty array, an array full of, say, zeros, and it's going to have the same dimensions as my horrible list here. And then I'm going to do a triply nested for loop because, of course, there are 3 indices, right? And so I'll start I equals 1. I'm going to go I is less than the first dimension of the horrible list, and then I'm going to iterate I. And then inside that loop, I'm going to do another loop with the second dimension, and I'm going to do another loop with the third dimension. I'm going to say that, well, the new list, the ijkth element, is going to be f of the old list. And what does this do? This produces this list, which, to its credit, is what I wanted. It's f acting on all of these things. But let's say I have an inkling that maybe there's a more efficient way to do this in Wolfram language. I could say, I'm new to Wolfram language, and I hear it works functionally so that loops are usually not the right thing to do. Could you rewrite the code that turns my horrible list into my new list in a more Wolfram way? And something I want to point out here while this thinks is that I have asked it to refer to my horrible list and my new list and the code that turns the former into the latter. So it's aware of what's in this notebook here and can use built-in symbols and symbols that I have defined and code that I have defined myself to transform one symbol into another, and it can use all that in its answer. So here's the original code with loops that it's replicating, and it says, well, you know, the functional programming approach in Mathematica and Wolfram language is just to map it at level 3. And so if I insert that, I was clicked up here, so that's where it inserted, but we can just move that down. Can see that this output looks right, and let's go ahead and just put a matrix form on it so that it appears the same way as before, and we can confirm that this is exactly the same thing that we had before. It does exactly what we want, and now the entire code to do it, instead of 3 nested lists, just look like this. And this is much nicer. And you know what? We could learn about other functionality as well while we're at it. Let's say, suppose that f is sine. Can that make the code even more efficient? So this knows about an attribute of sine, and I mean, we're getting a little, in the weeds here, but sine has an attribute called listable, and Notebook Assistant knows about this because it's discussed in the documentation. What listable means in Wolfram language is that if you apply the function to a list of any depth, it will just automatically thread itself over all of the lowest level elements. So in fact, we didn't even need to use map. We could have just taken sine of the entire list. And once again, if we insert and evaluate, you'll see that that produces the exact same list there. Let me again, just for convenience's sake, put a matrix form around this thing. And we can see that if f were sine, we could get away with just taking sine of the horrible list, and bam, we'd be done with it. And it's not just code, for what it's worth, that Notebook Assistant is aware of in your notebook. Suppose I have this picture of my lovely Dumbo boy, Michi. I could say something like, how could I turn my boy into a black and white image? Hey, to convert an image to black and white, you should use binarize, and you can pick different binarization thresholds. And let's just insert this. And there he is. And, maybe that's not quite what I meant. Maybe contextually the Notebook Assistant could do better if I gave it a little bit more information, because this is a black and white image, right? But when you think about black and white photography or black and white movies, you're not thinking about a movie or a photo that has just 2 colors, black and white, right? So let's kind of give it some historical understanding without even getting technical about it. Let's just say, instead of just black and white, could you make it black and white like old movies or black and white film? And because in addition to having access to all of the Wolfram language documentation, this is built on top of LLMs, this thing has some kind of historical context, historical understanding of what I mean when I say a black and white old movie. So this says, oh, okay, well, if you want that, it's going to give us a cute little name, My Boy Film Style, and then it says you can use color convert and convert it to grayscale, and there it is. So Notebook Assistant has access to everything in your notebook, whether it's code or images or graphics or graphs or whatever it might be. But it also has access to the knowledge base that powers Wolfram Alpha. You may also hear this referred to as our entity framework. And something I want to indicate here is that the entity framework is full of information that is hand-curated by people here at Wolfram Research. This is not something that's pulled randomly from the internet. It's not some hallucination thing that exists inside the parameters of the underlying LLM. This data is stuff that actually is hand curated by real people here. So we could do things like, let's ask, you'll see how this comes in just a second. Say, how could I make a 3D plot of the terrain around a mountain? Okay, so it says we should use geo-elevation data, use listplot3d to plot it, maybe something else, but listplot3d or related functions. And something else that I should point out is that these are links to the documentation. So if I just click on, say, geo-elevation data, I get the documentation right there. And here we have this, and let's go ahead and run it. So we're saying that Everest is going to be using this built-in geo-elevation data, and there's going to be a disk of radius 10 kilometers around Mount Everest. And this has generated a nice region for us. So this is actually kind of what we want already. But I'm not actually sure if listplot3d will work with a region. Yeah, I think if you get rid of this region part here, it gives you just a quantity array. And then listplot3d would work. Okay, the color function is not right. That's kind of a reasonable thing to guess, but it's not quite right. Let's say dark rainbow. And of course, you could just get rid of this. The error message here is quite helpful. And there we have it. That is the 3D elevation around there. Although, like I said, I actually didn't know about this, this way of doing it. I think it said automatic, and then you could ask for it as a region. I don't find myself working with topographic data too frequently, but that is neat to know. Regions are a totally different thing in Wolfram language, and we won't have time to get into them, but suffice it to say that you could do something like integrate the function sine of xy over this surface when you have this region, or you could just send this to a 3D printer. It's really neat stuff. Okay, a couple more examples here using the built-in data. We could ask something like, make me a plot of Asia where each country is colored by its total population. And while that's computing, I do want to point out something that I have neglected thus far. You can see here that there's a focus button. And what this will let you do is it will let you pick which Notebook Assistant is looking at any given time. By default, it will just focus on whatever the last notebook you interacted with was. That's what I have here. This is the Wolfram Notebook Assistant and basic chat functionality notebook, so it's focused on that. And here we see our first example where I asked it to make me a plot, not really show me how to make it, but to make it. And Notebook Assistant doesn't just have access to the documentation in your notebook and the sociological and geographic and economic and all that data. It can run Wolfram language by itself. And so here it did run Wolfram language by itself, and it's produced this map. And you can see this is a pretty bimodal distribution. And if you just click on the Wolfram language evaluator box here, we can insert and evaluate once again, and we can get a sense of how this works. So maybe if this is how we do population, maybe if we did GDP, we'd get that as well. And indeed we do. And again, this information is hand curated and sourced by people here at Wolfram Research. A couple more examples using some of the built-in data that I thought were neat at least. My background is in physics, so of course I thought to ask it this somewhat silly question. Say, plot the first 4 eigenfunctions of the quantum harmonic oscillator. So we learned about a function here, d eigensystem. Okay, we get our quantum harmonic oscillator operator, the Hamiltonian for this thing. We got some kinetic energy and potential energy. I won't bore you with the details. But if we insert and evaluate this, let's see what happens. I have a suspicion, that it won't work. And that's because it hasn't defined these constants. So these are physical constants, and these are correct. These are what are supposed to be in the equation. But if you don't have a value for part of your plot, you can't really plot it. So could you make up some values for the physical constants so that the plot actually works? And when you work with LLMs, the output is not strictly deterministic. There's always some variability. Very frequently when I run code like this, it will just go ahead and set all those physical constants to 1, for example. Here it's going to set, we're going to set, okay, so that's the reduced Planck constant. This is, oh, it says it right there. I was going to say, I know 9.11 times 10 to the minus 31 kilograms is an electron and an angular frequency. Let's see if this is even visible here. I might instead ask it to just set them to 1, but let's see. Okay, and because here there are quantities, it's getting a little frustrated that we're using quantities here. So I'm going to offer another correction. Again, generally I don't need to do this for this input or most inputs really. As you've seen, everything more or less just works. One correction here or there. But I could say the quantities are messing things up. Please just set all of the unknown. You don't really have to correct typos, but I like to. Unknown constants to 1, making them unitless. Okay, let's try one more time. And there we go. We finally, after a little bit of effort, but not so much effort as you might imagine for plotting eigenfunctions of a quantum harmonic oscillator, we can see what these eigenfunctions look like. And we can see that they alternate between being odd and even. It's pretty neat. And of course, once you have this code, you can go up here and say, oh, well, if that's the case, I bet I could get, say, the first 7 just by replacing that 4 with a 7. It's the only place a 4 appears, right? Oh, and that's neat. There's a normalization method here. Long story short, these wave functions represent something related to probabilities. So if you integrate them a certain way, the total area has to be 1 because the idea is that the particle has to exist in some state. So there's a probability of 1 if you look all the way to the left, all the way to the right, that the particle exists. But that is very neat. Look at that. And, we're not biased towards physics, right? We could ask things about some basic chemistry maybe. Like let's say, make me a plot of density versus atomic number for all of the elements in the periodic table. Also, put a nice frame on it, Put the corresponding element names in tooltips so that they don't crowd the image. Okay, says we should use entity list and entity value. I think that's very reasonable. It's grabbing the densities and atomic numbers and the names. It's putting these all together. Okay. Let's give it a shot. And there we go. And I think this is a really neat little demo. Although here I can see that it's accidentally put all of the elements in the tooltips. That's a new one for me. We'll see if we can fix that in a second, though I don't want to get too bogged down with it. The important thing that I think that we see from this is that just by asking pretty basic questions, we can access information about the world, and we can see things here. Say you're a brand new chemistry student, and you don't know why it's called the periodic table. Why is it periodic? Why is it arranged like that? Well, you can see right here that, we're not joking about the periodicity. You get a bump, and then it goes down, a bump, and it goes down, and these correspond to the rows of the periodic table. So these rows have real physical or chemical meaning. Like I said, I'll give one shot here. Looks like all of the elements wound up in the tooltips for each element. Make sure each point has a tooltip with only its respective element name. And we'll give it a shot, we'll see. It's using a slightly fancier way of doing this. At a glance, I think that should work. We have this, and then if we mouse over, we indeed see it might be a little small in the recording, but you can see that there are tooltips here that say things like dubnium. Who knew there was an element called dubnium? Probably a couple of you, but not me. And let's do just 2 more examples. Let's do a math one really quickly. Let's say construct a geometric scene that has 3 circles all intersecting at a single point. Let's see. Notebook Assistant can also be a good way to learn about functionality that you might not know about. I mentioned before there are about 6,500 different functions in Wolfram language, and even if you work here, chances are you probably don't know all of them. There are probably whole topic areas that you don't really know too much about. And Notebook Assistant can be a great way to kind of learn about these. So let's see here if this thing works. Okay, circle through is complaining there. Thing is, I think we don't need this last part. And again, this is a case where usually if I ask something like this, it just works. This is just like when you're in a lab as a student and something isn't working and then you call over the TA and then it starts working. And here we go. Just with that part, we've constructed these 3 circles here, and if we move the points around, we can see how this works. And they all intersect at this point here. Oops, I've kind of moved it out of the way, but there we go. And that's because each of the points here has a point A shared in common. So this is a circle through any 3 points. There's symbolic points here. And then we create a random instance of the scene. Because, of course, as you can see, you can move around the points A, B, C, and D. And there are infinitely many different variations that all satisfy the thing that I've asked for. And this is just one particular random instance of it when we generate it. There's another. And, I didn't plan for this, but let's not leave out the biologists. Maybe we can say, show me the taxonomy of Vibrio cholerae. Nasty little bug. And here, it's using Wolfram Alpha. So it's interpreted this in a way that thinks that Wolfram Alpha might be the easiest way to go. And there we have it. And I wonder, I don't know about this one, but is it possible to do that using, let's say, Wolfram language instead of Wolfram Alpha? I wonder if that's real. Let's see. Okay, so yeah, that is not a known species, though I do wonder. Of course, I pressed the wrong input here. Let me go back to my chat history. So all your chats are saved in a chat history here. I pressed control apostrophe when I meant to press control equals. Let me move this over just a little bit. Okay. Say Vibrio cholerae. So it is in there, and I wonder properties. You can check all the properties that exist. So you can extract things like the kingdom and the genus. I almost said the genus. Fascinating. And other things from here. Number of chromosomes. So these things all do exist, but not quite the way that it was represented here. So I do wonder here. what the difference was between what it gave us and the truth, so to speak. Okay, so we just needed taxonomic species, and I wonder if that would have worked. Taxonomic. Okay. I'm not sure about that one. Sorry, biologists. Okay, one last example, this one about creating a little interface. Let's say, how could I publish a web form where somebody types the name of a chemical, like a common name or a smile string or something like that, and they get back an interactive 3D plot of that molecule. I mean, that's kind of a big task, right? Create a form where somebody can enter in, some kind of arbitrary phrasing of a chemical, and it generates a 3D plot of the corresponding molecule, and then also publish this form to the web for anybody to use. It seems like a bit much. So let's insert and evaluate here. Okay, let's insert and evaluate here. I see there's an issue with this. I think we just don't need to. Put this here. And if we then cloud deploy it, let's see if it works. So here's a window, and let's go ahead and type caffeine. Okay, so that didn't work. Let's have a look really quickly here. Okay. I don't think that's a particularly reasonable conversion. I think asking it to generalize to smile string has caused it to add some complexity that's not needed. But let's also just check here really quickly. Deploy it again. Hey, there we go. Nice and 3D right here, live on the web. And if you were to painstakingly type this address as well, you too could access it. Of course, if you use Cloud Publish, you can give it a particular URL like molecule plotter or whatever you want. But it works. Needed a little adjustment, but if you were to go to the documentation for form function, I think you'd have seen how to do it pretty quickly. Okay, finally, let's talk about chat cells. So far, we've been dealing with the Notebook Assistant over in its separate window, right? Chat cells are a way to interact with LLMs, including the Wolfram LLM kit, right in your notebook. So take this example plot, right? It's a plot of sine of x as x goes from 0 to 2 pi. We love to see such a plot. You can open up a chat cell just by pressing apostrophe. And there you go. And I could do something like, how could I make that plot rainbow colored based on the value of the function? Also make it thicker so I can see the colors more easily. In chat cells, you have to press Shift Enter, just like a regular line of Wolfram language code. And because I have some weird magnification settings for this recording, this looks very large, but generally speaking, this will look totally normal on your end. So here we go. We kind of see a similar style of response where we can insert and evaluate some code, and it explains the changes for us. And if I click Insert and Evaluate, we do indeed have a thicker line where we have some coloring based on the height. Now, for some reason, it likes to turn off color function scaling. It doesn't need to do that, and in fact, that's why this turns purple here. It's scaling only from 0 to 1 instead of over the full range of the function. But there we go. Again, sometimes it'll do something like that. Sometimes it won't. Usually it won't. But there we go. It gives you a starting place at the very least, and oftentimes it just gives you the solution you're looking for. And we're going to finish off with just a couple of tips and tricks about chat cells so that you can kind of see how they're different from Notebook Assistant, even though they work in a fairly similar way. So like I said, you can always start a new chat cell by typing an apostrophe here. You can type tildes when you start a cell like this. Just type a tilde, and it will create a chat block. And each of these blocks, so let's say I put another one here, and I say blah, 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 and then I put a chat cell. This chat cell will only know about the stuff that exists in its own block. It won't know about the contextual stuff above it or below it in the notebook. If you do want to type your own Wolfram language code in a chat cell, let me just open another one here. I could say something like plot the function, and I'm just going to type a / like you see. I'm going to say sine of x plus x. And then just press Shift-Enter. And it's going to understand this as a piece of Wolfram language code. So you can directly put Wolfram language code into your queries just using a /. And there you go. It's given us a range of -10 to 10. Why not? Seems reasonable. And of course, if you ask it for a range here, it would do that. It's worth noting that, we've been in a chat notebook this whole time, a chat-enabled notebook like you see here. It's just a normal Wolfram notebook that also allows you to use chat cells. And then I think an important thing to note is that chat notebooks are spatial. This is kind of implied by this chat block idea. A chat cell by default will be able to see everything above it. Usually in a Wolfram language or in a Wolfram notebook, the way it works is that once you evaluate something, anything that you evaluate in the future can depend on anything you evaluated in the past. So in a sense, it's kind of temporal. Chat notebooks are different. A chat cell knows about everything above it in the notebook. And I'm kind of making a bunch of hand gestures you can't see here. But say, this chat cell knows about everything above it, and then it stops because it hits this block. But this chat cell, for example, knows about everything that happened above it in the entire notebook. And it doesn't know about things that are below it. So they are spatial versus the more standard kind of temporal Wolfram language cells. And something that's nice about this is if you have LLM Kit, you don't need to do any setup at all. Everything just works automatically and your service will be set to Wolfram here. But if you just click on a chat cell, the little thing that you see on the left-hand side, the little icon, you can pick between different personas. You can add and manage them and add and manage tools. You can pick different models and, hey, because we're in a video, I'll just show you live. So if I click on this, right, I can click on models and I could go to any model that I provided an API key for. So I have an OpenAI key on here, for example, and I can go through and I can pick whatever particular model I want, and so on. So you can pick for any individual chat cell, or you can set a default, but you can pick for any individual chat cell what model you want to use. So if you have different ones and you have a particular need for something that's not the LLM kit that powers Notebook Assistant, you can do that just fine as well. And you can talk to multiple models all in one notebook. And that's basically it. I hope that this gave you some ideas about how you can turn your own rough ideas into computation with Notebook Assistant and how you can use chat cells in order to access LLMs directly in your notebooks.